Now moving on to our next problem now. Now in this case, if you see that there is a capacitor of capacitance 79.5 microfarads which is connected in series the non-inductive resistance of 30 ohms across a 100 volts 50 hertz supply, which means there is a capacitance which is connected in series with a resistor, and it is across a 100 volts AC supply. So when you are trying to do the problems, try to draw the figure first. It will help you a lot. 100 volts 50 hertz, and this is your R, which is 30 ohms. This is your capacitance, it is 79.5 microfarads. Okay, now both these elements, they offer different impedance. The impedance offered by it is R, whereas the impedance offered by it is minus J by omega C, isn't it? So now we will try to calculate the impedance, the circuit current, and the instantaneous equation, the power factor, and the power constraint for these things. So let me start with the basic figure, resistor and combination with the capacitor. So first of all, determine the impedance. Now the impedance offered by it is R, whereas for this one it is minus JXC, or I can write it as minus E by omega C. So my Z, it is a combination of this one and also this one. So R plus minus JXC. What is R? R is 30 ohms plus minus J. J is an imaginary term. XC is 1 by omega C, right? So 1 by omega. See, frequency is 50, right? So F is equal to 50 means I can go with omega is 2 pi F. Okay. So first of all, let's try to write what is given for us. Then see. What has been given? This is resistance and the capacitance, the voltage, the frequency, and omega. See, omega has been calculated here. It is 314.15. So let me draw it again. This is R, this is minus JXC or minus A by omega C, where omega is calculated, it is 314.15, right? So impedance R plus minus JXC, or can be written as minus J by omega C. What is R? R is 30 plus minus J by 314.15 into, what is C value? C value is 79.5 micro is there. Don't forget these things, 10 to the power of minus 6. If you calculate it, you will get somewhere around, I think it is 28, it is somewhere around minus 40, I think. So let me calculate. It is somewhere around 40. So this is my impedance. It is 30 minus J 40 ohms. It is in rectangular format, right? If you want to convert it into polar, you'll get, you try to convert it into polar with your calci, you'll get 50 at an angle of minus 53.13 degrees. Okay, so this is your impedance. So the impedance of the circuit, see, this is the value of Z. We have substituted here, and see, 30 minus J40. Okay, so now we want current now, right? How is current calculated? It is V by Z, isn't it? What is V? 230 at an angle, sorry, it is 100, right? So my bad, it is 100, 0 by impedance is 30 minus J40, right? I can write it as 100 at an angle of 0. You convert this one into polar, 53.3 degrees. So what I'll get, I should divide these magnitudes. I'll get 2 at an angle. See, angles should not be divided, they must be subtracted, right? 0 minus of minus 53.3. What I'll get? Plus 53.3. This is my current. So this is my magnitude and this is my angle. Magnitude C, circuit current. Magnitude they have asking, magnitude is 2 amperes and phase angle is 53.3. See, when compared to the voltage, current angle is higher. So the power factor will be leading in this case because the current will be leading. Try to remember this. That we will see in the next slides. Now this is current. Now they are also asking instantaneous equation of the currents. What is instantaneous equation? I already told you, or the phasor equation we call it as Im sine omega t. What is Im sine? This is only RMS value. I always told you that you are using only 100. This is RMS. So you will get the current also in RMS. So how to get maximum value? Imax. It is root 2 into IRMS. So root 2 into 2. What is root 2 into 2? You will get somewhere around 2.828. Sine omega, we have already seen it is 314.15. I'll just write it as 314 t plus phi is also there. Plus what is the angle? 53.3. This is the instantaneous equation. Try to remember this one. Okay, so see the current, this is flowing, I is equal to V by Z. I substituted these values. So this is the same thing which we have obtained here. Okay, now the magnitude, this is the phase angle. And the instantaneous equation, see what we have obtained. Im is root 2 into I value, IRMS. It was root 2 into 2, it was 2.828, I think. Yeah, 2.828. So if I substitute here, what I'll be getting? My current is 2.828 sine. There must be a phi here. So sine 314t plus 53.13. This is the angle of I which we have obtained earlier, right? So this is the way how we determine the instantaneous equations or phasor equations. Now we will move on to power factor now. The power factor, you know, it is a cos of angle between voltage and currents. The voltage was 100 at an angle of 0. Current was 2 at an angle of 53.3. So what is the angle between these two? 0 minus 53.3. So you will get cos of minus 53.3. You will get somewhere around 0.6, I think, right? But see, which is leading? Current is leading. If current is leading, I'll take power factor is also 0.6 leading. Okay. So this is how it is calculated. Power factor is 0.6 leading. Okay. Now what is P? It is VI cos phi. All RMS values. Magnitudes. This is magnitude. This is also magnitude. Only RMS values. So it is 100. It is 2. It is 0.6. You will get somewhere around 1 volt. If you want Q, it is mod V mod I sine phi. It is 100 into 2 into sine phi is 0.8. In this case, it is 160. The units are for power. It is watts. For reactive power, it is VAR. This is how power is consumed. Okay. So the power factor is 0.6. I should write it here leading clearly. Don't forget to write whether it is lagging or leading. And this is active power consumed 120 watts. And this is reactive power 160 watts. Okay. Additionally, as I already told you in the last video, you might be asked voltage drops across individual elements. You will be asked about voltage drops across individual elements. Now in my circuit, what are the individual elements? This was fixed at 100 at an angle of 0. Right. So voltage across supply, it is fixed, right? It is at 100 at an angle of 0. And the current in the circuit, it is at 2 at an angle of 53.3. Now I should calculate voltage across resistor and capacitor individually. So voltage across resistor, it is equal to I into Z, where I is 2 at an angle of 53.3 into, for a resistor, the Z value is only R. I told you already. And what is this R value? R value is 30 in this case. If I don't have an angle, I'll directly write it as 0, isn't it? So 2 into 30, it is 60. It's an angle of, what is this one? This is 53.3 plus 0, it is 53.3. Now if I want voltage across capacitor, it is also Iz, where Z is nothing but minus J by omega C, isn't it? So it is I, it is 2 at an angle of 53.3 into 1 by omega C, we have seen it in the last class, it is 40. For minus J, what I will be getting? I will be getting minus 90, isn't it? I will be getting minus 90. So in this case, now see what is the angle now and what is the magnitude. 2 into 40, it is 80. Angles must be added. So what I will be getting, it is minus 90, 53, it is 40, sorry, it is somewhere around 36.6 or 7. This is the voltage. Am I clear? So this is how you will be writing expressions. Voltage across resistor and voltage across capacitor. Okay. Now, I hope you have understood how to determine the different quantities in RL circuit and also RC circuit. So I'll end this video here, and in the next video we will see a different type of problem on RL and RC circuits. Okay.